A linear equation would be something like 3x minus 2 is equal to 4, and we could easily solve that by moving terms to one side of the equation and perhaps doing some division at one point, and we'd solve for a value of x, and there'd be a single value of x that satisfies that equation. A linear equality is less strict. It says that one side has to be less than or equal to, or less than or bigger than or equal to the other side. We can approach a linear inequality in a similar fashion. We just have to be mindful of certain operations might affect the direction of the inequality. Let's look at this one. 3x minus 2 is less than or equal to the number 4. I'm going to treat it somewhat like an equation. In this case, I'm going to add 2 to both sides. If I add 2 to both sides will increase by the same amount, and the inequality will be preserved. In other words, the direction of the inequality, less than or equal to, will stay the same. And if I do that here, I'll get 3x is less than or equal to 6. I'm now going to divide by 3, and if I take a third of one number that's less than another number, that inequality is going to be preserved. Taking thirds of things is going to preserve the order of numbers on the real number line. So in this case, I'll divide by 3, and I get x is less than or equal to 2. So there are many numbers that satisfy this inequality, all the numbers that are less than or equal to 2 on the real number line. This includes 2 because of the equality in the inequality, and everything to the left of it. In interval notation, our solution can be expressed as the interval from minus infinity to 2, and because it includes 2, I'm going to put a bracket there. Let's look at another inequality. Let's solve 4 minus 2x is less than 8. I'm going to subtract 4 from both sides, and doing so will move both sides down equally, and therefore the inequality will be preserved. I'm now going to divide both sides by negative 2, but this is where you have to be careful. If you divide an inequality by a negative number, you're going to change the order of things on the real number line. They'll flip around, and that will change the inequality as a result. So yes, I'll have negative 2 on the other side, but observe how now x is greater than negative 2 as opposed to above where the inequality was less than. So here's negative 2, and I can take everything to the right of it because I did not start with equality. Equality won't exist for the solution either, and I should not include negative 2. And so my solution is all numbers to the right of negative 2, so that would be the interval negative 2 to infinity. The parentheses indicate that I'm excluding the number negative 2. Let's apply this to some pre-calculus skills. Suppose I have a function called f, and its value at x is obtained by taking the square root of 8 minus 3x. If I'm going to take the square root of a number, I better make sure that that number is non-negative. I can take the square root of 0. I can take the square root of positive numbers, but I cannot take the square root of a negative number. So I require that 8 minus 3x is greater than or equal to 0. Because this is the number that I'm going to take the square root of, and that I have to ensure is non-negative. I now solve the inequality. I'm going to add 3x to both sides and move it over. I'm now going to divide by 3, and I'm saying that x has to be less than or equal to 8/3. Here's 8/3 on the number line, everything to the left of it, including 8/3. And so the domain would be minus infinity to 8/3. I put a bracket here because I had equality here and I want to include that. Notice if I was to evaluate right at that endpoint of the interval at 8/3 and put it into this expression, the 3's would cancel. I'd have 8 minus 8, and I'd get 0 under the radical. So this is square root of 0. Square root of 0 is defined, and it's equal to 0 because the square of 0 is itself 0. Let's look at another example. I want to find the domain of the function g of x, which I obtain by taking 1 over the square root of 2 plus x. For the radical part of the expression to make sense, I need to require that 2 plus x is greater than or equal to 0, just as we did in the previous example. But when I actually achieve a value of 0 under the radical, I'll have a result which is 0, and that would result in dividing by 0. So I want to exclude that particular point right where the radical expression would equal 0 itself. And that requires now that 2 plus x is strictly greater than 0. I don't have equality anymore. Moving things over, x has to be bigger than negative 2. I don't want to include negative 2 in this case, because if I did, I'd be dividing by 0. And so the domain is all numbers from negative 2 to infinity, excluding negative 2 by including the parentheses as opposed to brackets.